Okay, so the title of the project is NLP and Machine Learning for Automated Requirement Formalization. The principal investigator is Cheng-Guo Lin from University of Sheffield, and co-investigator was Kevin Lano from KCL, and I was working on that project as a research assistant. And next, please. Yeah, the aim of the project was to construct a framework for requirement formalization, where we could apply different NLP, machine learning, or deep learning tools to apply different pathway to requirement formalization. Alternatively, we would like to evaluate different approach on set of standard tasks for whether mining unstructured document, structured document, or semi-structured documents. And finally, the final goal for this project was to provide the guideline for selection of requirement formalization techniques according to the specification of particular task. So which techniques is more appropriate for which particular task. Next slide, please. Yeah. In order to do this project, we carried out a systematic literature review of existing approaches, and we went through the approach that used NLP, machine learning, and deep learning. For the first round, we got into 250 publications. Then we applied some criteria, inclusion, exclusion criteria, and finally we got to 49 papers which we investigated deeply. And could you please go to next slide? Yeah. And the main findings of this research are summarized here. We found out that the heuristic NLP approach are the most common requirement formalization techniques in most studies. And they primarily applied for structured and semi-structured data, and usually not for unstructured data. Additionally, we found out that deep learning techniques are not widely applied in this domain. Instead, some machine learning, classical machine learning techniques such as decision tree, SVM are applied in this domain. And importantly, we got into the conclusion that there's a lack of standard benchmark cases for comparison of requirement formalization approach to compare to compare them, to check the efficiency and so on. So next slide.
This is the next slide, I'm afraid. Shekoufeh, are you still there? Oh, it looks like we've lost Shekoufeh. Well, that's not particularly helpful then. No, Shekoufeh, are you still here? Can you hear us? You're still on the call. Yes, she can hear us. We can't hear you. Quite a lot of a sudden. No, she's not muted. Please. Kevin or Cheng-Wei, do you want to take over the rest of the presentation? Would that make sense? Just so while Shekoufeh is sorting herself out. Yeah. She's still around.
Are you there, Shekoufeh? There's something wrong with her sound.
Yes. So, Kevin, do you want to carry the presentation?
I can do this. Actually, this was Shekoufeh's work, of course, but yes, we looked at the different papers, and particularly we found there were flaws in the way that evaluation was carried out. Typically, a paper might select some examples, and those examples were different to the examples in other papers. So there wasn't a standard set of cases which were used for different papers and which therefore could be used to compare them. And especially for heuristic approaches, it's it's hard to tell how general those approaches might be because they look at only a few input cases, a few kind of requirements statements. In principle, deep learning could be used, especially in cases where there's unstructured source information. But again, this seemed to be underused in the example in the publications we looked at. So we concluded from this that we needed to create some standard benchmarks or select some standard benchmarks, and also to define evaluation criteria so that different approaches can be compared on the same basis on a level playing field. Now, other communities like NLG and speech processing have already established this kind of framework. They've established this kind of evaluation framework and case studies, and that has helped to establish these fields and develop these fields. Okay, next slide. So the outputs of the project, first of all, we created a DSL to define pipelines, NLP processing pipelines for requirements formalization, and we did two versions of this, one based on SQL and one based on OCL, and we defined a transformation from the DSLs to Python to use the NLTK NLP toolset, and we evaluated them with some typical requirements formalization tasks. Okay, next slide. One of our main outputs is the requirements formalization repository, which is at this GitHub, and that the aim of that is to provide a central point of reference for requirements formalization research. We're going to populate it with links to state-of-the-art research, evaluation cases like standard cases, which are usually real requirement statements from actual projects rather than just fabricated ones. Some tools for evaluation, and the results of the evaluation, and we might produce a kind of ranking, a score sheet for different approaches. But generally, it's a resource for the requirements formalization community to improve the practical application to real problems. Okay, next slide. So that's what it looks like at the moment. There's a set of case studies, evaluation results, evaluation tools, different approaches. We've got 3 or 4 different approaches that have been executed and implemented in Colab, for example, and the results of formalization. Okay, next slide. Okay, yeah. So we've taken a set of cases of real-world requirement statements. The biggest set is 25 cases of real-world user stories, and there's also some cases from a medical informatics system of unstructured and structured requirements, and we've done the evaluation for several approaches with several evaluation algorithms or processes, and the results are on that GitHub. Okay, next slide. So the comparisons and the evaluations, 3 ways to evaluate approaches. One, if you've got a reference model, a reference model would be like a gold standard model, formalization typically produced by a human expert. Then you can compare the reference model to the formalization that your RF approach produces from the same source. Then you could also do an internal quality check on the formalized model to make sure that it makes sense as a UML model. Typically, we're creating UML class diagrams and use case diagrams. And then finally, you can compare the formalization to the source to check that, for example, how many verbs, how many nouns have been actually expressed in the formalized model. So like completeness of the model compared to the source. Okay, next slide. So future work, well, this is just a starting point. We're now going to be working kind of post the project, obviously post funding, but we're going to be working to populate that repository with more case studies, more evaluations, and of course to get publications from that. We have a PhD student at King's who's working in this area, and we hope that he'll be able to do some of that work in his PhD. And we also intend to get an EPSERC proposal in the following year. Okay, that's it, I think.